Alright, in this video we're going to focus on adding rational expressions with uncommon denominators this time. If you haven't watched my video on adding rational expressions with common denominators, you might want to check that out first just to get a little bit of a basis for this. But now we're going to be dealing with uncommon denominators, where our denominators are not the same. So, with that said, let's jump right in. Let's say we have these rational expressions, 5m over 3z plus 2z over 3m. And right now, they do not have common denominators. They have a common part to their denominator. They both have their denominators with a 3 in them, but the variables are different. So our goal is going to be to figure out how can we get the denominators to be the same. And it's all going to come down in this example to the variables. Since we both have a 3 in our denominators, I'm going to leave those alone, but this denominator has a z, this one doesn't. This denominator has an m, this one doesn't. So what we're going to have to do is we're going to take the m from this denominator and we're going to multiply top and bottom on the left side by m. And what that's going to give me is 5m squared over 3mz. I just like to put them in alphabetical order. And now that we have a denominator of 3z, whoops. Let me try that again. Now that we have a combinator of 3mz, what we're going to need to do is get a common denominator of the same thing from here. So we're going to take the z from this denominator and we're going to multiply the top and the bottom by that z. And that's going to give me 2z squared over 3mz. And now I have a common denominator. Nothing is all that different, and since I've multiplied top and bottom by the same factor, these are all still equivalent, but since I have a common denominator, I can now do what I did in the first video, which was add these together. So, my new denominator, or the denominator in my added piece, is going to be 3mz. And up top, I'm going to have 5m squared plus 2z squared, and I'm done. I cannot do anything else because of the addition. I can't factor anything out because they don't share anything, and since they don't share anything on the top, I'm not going to be able to factor anything out at the bottom as well. So that's my answer. Let's rethink this real quick. We didn't have a common denominator to start with. We looked at the denominators and noticed they both already had a 3, but they had different variables. So I multiplied each side, top and bottom, by the missing variable. And that gave us a common denominator for both of them, which allowed us to add them together. Alright, let's take a look at a different example. It's a little more complicated, but it's the same idea. Alright, here we have the rational expression 6 over m minus 5 plus negative 2m over m minus 4. We do not have a common denominator. And unlike the last one, I can't count the m's that they both have as a common piece because the m's are not multiplying anything like the 3's were before. The m's are being subtracted or having a number subtracted from them. So, I need to get a common denominator. What we are going to do is we are going to take the m minus 5 and we are going to multiply top and bottom on the right side by m minus 5. Then I'm going to take the m minus 4 on the bottom and I'm going to multiply top and bottom on the left by m minus 4. And you might be thinking, this is going to be a lot of distribution. Here's the good news. you're going to leave the denominator in its pieces, m minus 4 and m minus 5. You're not going to distribute the denominator. There's no need, because ultimately we want to try to see if there's anything we can factor out. So now that we've got that set together, we will distribute the tops. Okay, so that 6 is going to get distributed into that parentheses and give me 6m minus 24. And this negative 2m is going to get distributed into its parenthesis, which will give me minus 2m squared plus 10. And now we can combine any and all like terms and see if we can do any simplifying. So, if I combine like terms, we're going to get negative 2m squared plus 6m minus 14 all over m minus 4 times m minus 5. And in some cases we would be done, but we're going to want to check this numerator. Can we factor this out into anything so that it cancels with stuff in the denominator? Because if so, we can then simplify. So let's use the diamond method to factor it out. Up top, I should note that I'm going to take out the negative 1. So this is really a negative 1 times 2m squared minus 6m plus 14. Taking out that negative because the negative as on the a can throw things off. So I'm going to have a positive 28 up top, a negative 6, and can we think of any whole numbers that multiply to 28 but add to 6? Multiplies to 28 and adds to 6. Well, you got 2 times 14, that's not going to work. You got 7 times 4, that's not going to work. So I'm going to say no. We cannot simplify this at all. So there is our final answer. Negative 2m squared plus 6m minus 14 all over m minus 4 times m minus 5. Alright, that one was a little bit of a doozy. We had a lot going on there, but it's good practice. We're going to try one more, and then we're going to call it a day for this. Alright, we have x over x plus 3 plus negative 18 over x squared minus 9. This is our last example here. And the reason why we're doing this one is because we're going to see that we can do a little bit of simplifying or factoring before we try to get our common denominator. And if you are thinking, I can cancel out the x and the x here, please go back and watch my simplifying rational expressions videos, and hopefully you'll see from those why you cannot do that. You just can't. So what we're going to do here to start off with is, this side looks pretty good, can't factor anything out. The top looks good. But this x squared minus 9, hopefully we recognize that this is a difference of squares situation, and I can factor this. If I can factor this, that might help getting a common denominator be a little bit easier. So x squared minus 9 is the same thing as x plus 3 times x minus 3. And I've got the negative 18 up top. Okay, and I'm trying to add to it x over x plus 3. Now this is really good, because look at the denominators. They both share an x plus 3. So what that means is I don't need to do anything to the right side. The right side already has an x plus 3. This side has an x plus 3. I need to get an x minus 3 on this side. So I can multiply this side, top and bottom, by x minus 3. And when I do that, I will now have a common denominator. I will have on the left side, x squared minus 3x over x minus 3 times x plus 3 plus negative 18 over x plus 3 times x minus 3. So I have my common denominators. Yes, they are out of order, but they are still the same because the factors are the same. So I can add them together now. I get x squared minus 3x minus 18 all over x plus 3 times x minus 3. And I know in the last example we couldn't do anything at this point. We were done. But that isn't the case for every single example, so we should always check and see, can we factor our numerator and then simplify this a little bit more. So up top I've got x squared minus 3x minus 18. That's going to give me 1 times negative 18 on top, or negative 18. Negative 3 down below, and is it possible to have two whole numbers that multiply to negative 18 but add to negative 3? And it is negative 6 and positive 3. So this is going to factor down to x minus 6 times x plus 3 all over x plus 3 times x minus 3. And wouldn't you have it, we can simplify. They both share an x plus 3, top and bottom, so we are going to cancel those out. And then we have our final answer, x minus 6 over x minus 3. And we are done. You'll probably notice that these examples in this video went from simple to more complicated, and that was on purpose. Sometimes they'll be easy, sometimes they won't. But we have the mathematical tools to tackle them. So hopefully you found this helpful, and good luck.